Okay, so let's move on to the existential quantifier now, and we'll talk about our first rule, which is existential introduction. So if Albert is funny, F.A., we know at least one thing is funny. So this inference is valid, and yet we don't have any way to demonstrate that yet. And that's why we need the rule of existential introduction. We need a rule that allows us to attach an existential quantifier, just like we have a rule that allows us to attach the universal quantifier. So here's a formal statement of the rule. For any formula P containing a name, A, and for any variable V not occurring in P, we may infer there exists a V, P, where V is substituted for A and P. Now, what does that actually tell us? Well, just look at some examples. First of all, without FA, it tells us that we can infer there exists an X, Fx. Fa here is P, right? It contains a name, which actually is A, that it doesn't have to be since it's variable up here. And we take a variable, V, in this case we choose X, though we could have chosen Y or Z or any other variable that's not in P. No, there is no variable in this one. And then we just infer there exists a VP where V is substituted for A and P. So we infer there exists an X, Fx, where X is substituted for A in Fa. Okay? So that's kind of long-winded. It's probably more obvious to you and when we don't explain it than when we do, but that wouldn't be responsible. So other examples, well, suppose we have F, A, B. What can we do there? Well, we can say there exists an X, F, A, X, right? What do we do in this case? We put on an existential quantifier and substituted an X for the B, or alternatively, we could have said there exists an X, or any variable whatsoever, since no variable occurs in there. There exists an X such that F, X, B. In this case, we would have just substituted the X for the variable A. So again, should be perfectly familiar to you, the process from universal introduction. Finally, if we have something with a quantifier in it already, suppose we have for all X, if Fx, then G of A. What can we do to that? Well, one thing we can do is we can write, now we can't use X because X is already there, but we can write there exists a Y such that for all X, if Fx, then Gy. Now, remember, whenever we do these, you have to be operating on the main operator, so we wouldn't have been able to stick the existential in front of the GA right here, right? We couldn't have done that because then we're not operating on the main operator. Here, what we have to do is put it on the very outside of the formula. Okay, so there's two important points about existential introduction, and the good news is that they're not restrictions. The points are that we don't have any restrictions with respect to existential introduction. So first, with existential introduction, you don't need to think about anything regarding the origin of the names for which you're introducing the variables. So if you'll remember, with universal introduction, we had to say, wait a minute, are these names in a hypothesis or an assumption? If so, we can't use them. You don't have to do that with existential introduction. And then second, when you are making a substitution using existential introduction, you can pick and choose how you want to do it. So for example, if you have, say, FAA, if you want to, you can infer that there exists an x, f, x, x. Stick x in for both occurrences. That's perfectly legitimate. But you could also just infer there exists an x, f, x, a. Well, why is that? Well, because there is an x such that fxa, namely a, right? So that's a perfectly legitimate inference as well. So let's look at a couple of simple proofs first. Go ahead and try this on your own. It's not very difficult. So we want to prove there exists a y and there exists an x, fyx, and all you really have to do is pay attention to your bookkeeping. We're going to have to introduce there exists an x first, and so we'll be introducing the x for the constant in this place right here, which is b. So our first existential introduction will be there exists an x, fax, where x has been inserted for b. And then our second introduction will be there exists a y and there exists an x, fyx. That will be on line 2 by existential introduction. So just 2 successive existential introductions give us the answer, give us the full proof. Now, you could also have proved this. Go ahead and try this. Okay, so from FAA, we derive exactly the same conclusion. Now this is even easier because you don't have to do any bookkeeping. All you have to do is choose one A and then choose the other. So there exists an x, fax, the same move as before, but we leave one of the A's. So we're allowed to just pick and choose like we said, and then we just add the other existential introduction in afterwards. So this tells us that there exists a y and there exists an x, fyx. It does not tell us that there are 2 separate ones, right? So in this case, the reason this is true is because of FAA. All right, so let's go ahead and do a couple more proofs where we get to combine existential introduction with some of the rules we already know from the universal quantifier. Go ahead and try this on your own. This should be doable. Give it a good try and then start us back up and see if you got it right. All right, so we got 3 assumptions here, and this is, deep enough to where we might not be able to see exactly how it's going to go by staring at it. But if we stare at it a little bit, we can see ways that we can start to sort of unpack the formula. So if you look at number 1, this is a universally quantified expression, so we could do a universal elimination on this, just remove the universal quantifier and stick some constants in here. Now the question would be, which constant should we use? And you look to your other assumptions to figure that out. Well, you might think, for example, how about maybe a little conditional elimination action? If you look at FAB and think about existential introduction, you might be able to introduce an existential that's going to give us the ability to fulfill this antecedent condition. So if you're going to think about that, why not try putting in A for X? If you did that, you'd come up with this. There exists a Y, Fay. If there exists a Y, Fay, then for all Z, not GAZ or not GZA. Remember, the X's are down here. You can't leave these X's dangling or you've got not a woof. So A's go in for all the X's. And was that a good move? Well, yeah, it looks like it is a pretty good move because now you can do an existential introduction on 2. Exists a Y, Fay. So what have you done here? You've put in Y for B, 2, an existential introduction, and you've done what we thought we could do, which is to satisfy the antecedent condition of 4, which allows you to do conditional elimination. Okay, did you get this far? If not, go ahead and pick it up from here and see if you can finish it up. All right, so we've got the universal quantifier for all z, not GAZ or not GZA. Again, it's always a good idea to think about removing the universal quantifier because that gives you some bona fide content to work with. The question would be, well, what should we put in for z? Well, look at what you're driving at, not GBX, okay? So it looks like we really want B to be showing up. And so maybe we should go ahead and try sticking a B in for Z. What happens if you do that? Well, then by 6 in universal elimination, you get not GAB or not GBA. Is that useful? Well, go back and look at your proof again. Look at the different assumptions. Which ones haven't we involved? We've involved this, we've involved this. Not that we can't involve them again. We can involve them as many times as we like, but we haven't paid much attention to this one. For all Z, GAZ. Oh, that's got an interesting relationship to this. What if we were to do a universal elimination on that? Now we can go to anything we want. We can go to GAA, we can go to GAB, we could go to GAC if we want, but it looks like it's going to make sense to go to B, right? So GAB, and now looks like we've set up a disjunctive syllogism, almost at least, because what we actually need is not GAB, which we get by 8 and double negation, and by disjunctive syllogism we got not GBA. Is that a good thing? Sure, it's a good thing, because now we have this existential quantifier that's something that we can add right on top, substituting the x for one of the constants, and of course what we want to do is substitute it for a. Okay? All right, let's do one more, and this one is an interesting one that allows you to sort of exercise your discretion on how you instantiate with respect to the universal and how you introduce with respect to the existential. So go ahead and give this one a try. So we have two assumptions here, and we're asked to prove something that looks a little bit complicated, and sometimes rather than sort of figure out the structure of that, you just want to sort of start breaking things up a little bit. So look at the relationship between 1 and 2 and ask yourself if there's any way that you can get these to interact at all. Well, this certainly is not the antecedent condition of this, and it certainly doesn't match this in any interesting way. But it might be possible to instantiate the universal in a way that allows us to create this with an existential introduction. So what if we tried that? Now, how should we instantiate the universal if that's our purpose? Well, notice that we want A to be here. And we're allowed to do that. Remember, the universal quantifier is unrestricted when we're eliminating, and so we could actually go to FAA if that's what we want to do. So if we give this a try, what do we get? We get FAA by 1 and universal elimination, and now suppose we introduce the existential on that, and we can do that again by selectively only choosing one of the A's to introduce on, and we get there exists an X, FXA, right? So we substitute an X for this A and add the existential in front. Okay, so that's just a very straightforward but very choosy way of doing our universals and our existentials, and that gives us for all X, FXA. Okay, then you want to stop and stare at this a little bit. What have we got? Well, we've produced this for all X, FXA, and we certainly have some symmetry here, FXA, FZY. But is there any way, the question is there going to be any way to produce this from this? And the answer is, well, maybe not just from this, but recall that we also have number 1, which we're perfectly allowed to use again. So we have number 1, we have for all x, f(a)x. And number 2, we have for all x, f(x)a. So f(a)x and f(x)a. Now notice what we've got here, f(y)z and f(z)y. So these variables are in the same order as the constant in the variable in 1 and 5. So why don't we just start playing with this a little bit? Suppose we go ahead and do a universal elimination on both of these. What should we put in for the x? What should we put in for the x? Well, we can put anything we want in, but since we're going to be doing a universal introduction at some point, we want to be careful we don't use something that is already in an assumption, namely a. So maybe we should avoid a here and go to something that's not in the assumption already and try b. So what if we went to FAB, 1 and universal elimination, and we also went to FBA by 5 in universal elimination? Now, we can put these together. We want to make sure we do it in the right order, right? So, but notice we have y on the inside here and on the outside here. So why don't we go think of y as a, right? So FAB and FBA would make most sense. So now we have FAB and FBA. Now, can we do a universal introduction on this? Well, if we did, we'd be introducing on the B, right? Z is going in the B space, and B, fortunately, is not in the assumption. So that's okay. So we were smart to do that, right? We have for all Z, FAZ, and FZA, and the only reason we could do that is because we chose B. If we had chosen A, we wouldn't have been able to do it. Of course, we could use C or D or anything else, but definitely we couldn't have used A. All right, so now we have for all Z, FAZ, and FZA, and now we can introduce our existential. Now notice the existential, it's very important that the existential is an unrestricted move because we're introducing it on the A now. A is in the assumption, but we don't care. Why don't we care? Because the existential quantifier can be introduced without any restrictions at all. Okay, so that's a very instructive proof. Both of these are very, very useful, and you should, before doing the study questions, you really should try to make sure you can reproduce these from memory.